Good morning everyone. Today we are going to discuss a fundamental scientific concept, Dalton's atomic theory. We will look at how to explain the theory, as well as the symbols and atoms associated with it. Get ready to dive into the world of atoms. Dalton's atomic theory states that all matter is made of atoms. These atoms are indivisible and indestructible. Atoms of the same element have the same mass and properties, while atoms of different elements have different masses and properties. Compounds are made when atoms join together in whole number ratios, with the ratio of atoms staying constant in the compound. Atoms are the fundamental building blocks of all matter and are extremely tiny. An atom is the smallest particle of an element that might or might not exist on its own and keeps all its chemical properties. Atomic radius is measured in nanometers, which is 1/1,000,000th of a millimeter. For instance, the radius of an atom of hydrogen is 0.1 nanometers while the radius of a molecule of water is 0.9 nanometers. Atoms are very important and can be combined in distinct ways to make molecules. For instance, oxygen and nitrogen atoms can link up to form an air molecule. Molecules are a mixture of two or more atoms joined together by chemical bonds and can differ in size and complexity. Chemical reactions take place when atoms rearrange to make new molecules. With exploration and study, we can comprehend better the behavior and interactions of atoms and molecules, and how this pertains to the laws of chemical combination, Dalton's atomic theory, and symbols of atoms of different elements. Common elements in chemistry usually have their symbols to represent them. Generally, symbols are written by one or two letters. The first letter is capitalized while the second one is usually lower-cased. For example, aluminum is represented as Al, carbon as C, chlorine as Cl, gold as O and oxygen as O. The table below shows some of the more frequently used symbols for elements. The measure of the mass of an atom compared to a 1/12 of a carbon-12 atom is known as atomic mass. Elements on the periodic table can have different atomic masses, ranging from 1 atomic mass unit for hydrogen to 40 atomic mass units for calcium. Such variations in atomic mass are used to determine chemical formulas, and how an element will react with other elements. Knowledge of atomic mass is a significant factor in understanding chemical reactions and the laws of chemical combination. Atomicity is the amount of atoms in one molecule of an element. The table displays the atomicity of different elements. Monoatomic elements such as argon, helium, sodium, iron, aluminium and copper have one atom per molecule. Diatomic elements including oxygen, hydrogen and nitrogen have 2 atoms per molecule. Polyatomic elements like sulfur and phosphorus have 4 and 8 atoms per molecule, respectively. Molecules of compounds are composed of atoms of 2 or more elements bonded together in specific numbers. For example, water molecules consist of 2 hydrogen atoms and 1 oxygen atom, while ammonia consists of 1 nitrogen atom and 3 hydrogen atoms. Carbon dioxide molecules contain 1 carbon atom and 2 oxygen atoms, and hydrochloric acid has 1 hydrogen atom and 1 chlorine atom. Nitric acid has 1 hydrogen atom, 1 nitrogen atom and 3 oxygen atoms, and sulfuric acid has 2 hydrogen atoms, 1 sulfur atom and 4 oxygen atoms. These molecules of compounds show how atoms of different elements combine to form a molecule. Ions are particles which carry an electrical charge, either positive or negative. Valency is the capacity of a particular element to form chemical bonds with other elements. A table has been created which displays a list of common ions, their associated symbols and their valencies. PowerPoint slide number 12 is about writing chemical formulae. To write the formulae, the symbol or formula of the metal or positive ion should be on the left, and the symbol or formula of the non-metal or negative ion on the right. Valencies of the elements or ions should then be written below, followed by the crossing over of the valencies of the combining ions. Polyatomic ions should be enclosed in brackets before writing the formula. Examples of formulae given include hydrogen chloride, hydrogen sulfide, magnesium chloride, and carbon tetrachloride. We can see the formulas of several compounds, like calcium oxide, aluminium oxide, sodium nitrate, calcium hydroxide, sodium carbonate and ammonium sulfate, with their symbols, valencies and formulas. Now let's move on to the next slide to explore the end of the Revolutionary War and the establishment of an independent nation. Molecular mass plays a crucial role in chemistry. It is the total of the atomic masses of all the atoms making up a molecule. When expressed in atomic mass units, it gives us the exact amount of each element in a molecule, vital for comprehending its composition and forecasting its properties and behavior. For instance, water has a molecular mass of 18 U, consisting of 1 H atom and 2 O atoms. Likewise, nitric acid has a molecular mass of 63 U, that is 1 H, 1 N, and 3 O atoms. Moles are a unit of measurement in chemistry equivalent to 6.022 x 10 to the power of 23 atoms, molecules or ions. It is also equal to the gram atomic or gram molecular mass of an element or compound. For example, the gram atomic mass of oxygen is 16 by 2, or 32 grams. And the gram molecular mass of water is 1 by 2 plus 16, or 18 grams. The number of moles, N, can be expressed in relation to the mass, M, molar mass, M, number of atoms or molecules, N, and Avogadro number, N_0. This can be represented as M equals N multiplied by N, or the molar mass, M, divided by N_0. Understanding moles and their relationship to other units of measurement is important in understanding the chemical reaction and laws of chemical combination.